Today we are going to learn about basic concepts related to visualization. Okay, so in this we will learn bit by bit. If a point lies above HP and on VP. Okay, so if a point lies above HP and on VP, you will be learning, you will be hearing this word on VP for the first time. So be remember on HP means it is top view. Okay, so above HP means we know that it is front view. So we need to find out what is front view, where the front view it is lying. Okay, so we know that in quadrant system there are four quadrants. Okay, so this is our first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, so you can see that if a point lies above HP and on HP, we already got the top view. Now we have to look for the front view. So above HP means, is our HP plane, correct? HP plane is our vertical plane. So above HP means our point, the front view can lie in either in first quadrant or second quadrant. So that's what. So the front view can write front view can lie in first and second quadrant. Okay, so the point will be lying, that is the point will be lying in first and second quadrant. Okay, now we'll see the second concept. If a point if a point if a point lies in front of VP and on HP, so we know that on HP means it is front view. Okay, so on HP means front view, we have to see further in front of VP means, so in front of VP means it is top view, so where the top view will be lying. So in front of VP means this is our vertical plane. In front of VP means there are two chances, our front view can lie in first and fourth quadrant, that is we can write, so top view can lie in first and fourth quadrant, so that is point will be lying in first and fourth quadrant. Similarly, okay, if a point lies behind of VP and on HP. On HP means it is front view, so behind of VP means it is top view. So we have four quadrants, vertical plane, this is horizontal plane, this is our first quadrant, second quadrant, third quadrant and fourth quadrant. So top view behind of VP means there are two chances, the front view sorry, the top may lie in second and third quadrant. So I can write top weave may lie in second and third quadrant. So that is point will be lying in second and third quadrant. Okay, similarly, if a point lies below of HP and on VP. So and on VP means this is our top weave. So below of HP means it is front weave. Okay, so below of HP means we have to see it. So below of HP means two chances. The point may lie in third and fourth quadrant, that is front weave. So we can write front weave may lie in third and fourth quadrant. It is point will be lying in third and fourth quadrant. So the point may be lying in third and fourth quadrant. Say if a point lies below HP and on VP means below HP means two chances, third and fourth quadrant. So the front may lie in third and fourth. That is, finally the point will be lying in third and fourth quadrant. Okay. Today we are going to discuss problem of points on side weaves. Okay. So in this problem, so we will be dealing with the side weaves here. So we will go with the question. A point P is lying. P is 30 mm in front of VP, 40 mm above HP, and 50 mm from RPP. Okay. So in this problem, so as we have know, so it involves three concepts. First, to identify the quadrant. So in front of VP, above HP means it is our first quadrant. So for the first quadrant, we know the notations. So VP, HP, XY. That means first we are going to draw this first quadrant, top view and front view. Okay. Okay. So we know that 30 mm in front of VP means it is top view. So top view it is drawn in the HP plane. So 30 means 3 boxes, and you put a point. So that is here the top view. Similarly, 40 mm above HP. So 40 mm above HP means it is our front view. It is 4 boxes. It is P dash. So now we'll show with the dimensions. This is 40 mm and this is 30 mm. Now you can see this 50 mm from RPP. This is what the side view. So where it is exactly means in the quadrant. So you can see this. So this is our HP plane and this is vertical plane and this is our RPP, right profile plane. So this right profile plane, it is adjacent to the vertical plane. Okay. So in this problem he is mentioning that a point P is 30 mm in front of VP and 40 mm above HP and 50 mm from the RPP. So this it will be there adjacent to the vertical plane. Okay, when it is drawn in the orthographic, so it will be like this. Okay, so front view, top view, this front view connected with the side view. Okay, so that means for this RPP we will be drawing another x1 y1 line at a distance of 50 mm. Okay, now to draw this side view with the top view, we will be using 45-degree angle line. Okay, so you just follow the procedure. Okay, now from this projection point, we have to consider a distance of 50, that is 5 boxes. Keeping this distance of 5 boxes, here we are going to draw x1 y1 line because it is 50 mm from RPP. So this is x1 y1 RPP, right profile plane. Okay, now we know that so side view will be there adjacent to this front view. So we draw a straight line. After this, we know that we have to draw an 45-degree angle line here. Okay, in order to connect the top view with the side view. So that is 0, 10, 20, 30, 40, 45. So mark a point. Then draw a straight line. This is your angle line. That is 45-degree angle line. Now from this top view, so you'll be drawing a straight line until it touches the 45-degree line. Then we project upward. Okay, so where these two lines are intersecting, so this point is our side view. Okay, this is what the say, and we can show the direction of the projection line. Okay, so this is what the side view. Okay, today we are going to learn about shortest distance problem in points. Okay, so they will be giving the shortest distance in this problem. So nothing but a arc distance we have to consider here. So in this type of problem, they will be mentioning about only one view. Okay, using the shortest distance, we have to construct all the three views. Okay, now we proceed to the question. You can see this is shortest distance problem. A point A is 20 mm above HP. Above HP means we know that it is front view. So we get it about the one view, and it is in the first quadrant. That means he is telling that we have to consider the first quadrant, that is VP above XY line and HP below the XY line. And then after that he is mentioning, and its shortest distance from the XY line is 40 mm. That means arc distance of 40 mm we have to consider to construct it. And then draw the projections, determine its distance from VP. Okay, so you all understood, right? In this problem they are mentioning only one view, that is front view, and then they have given the hint that we have to consider the first quadrant, and then they have given the shortest distance. So shortest distance means arc distance. So arc distance, that means we have to consider a compass here. Okay, so we know that it is in first quadrant here. So VP above the XY line, HP will be below the XY line. So we will proceed with the question now. Y. So you can see this 20 mm above HP. So 20 mm above HP means, so it is in first quadrant. So HP VP we have written. Above HP means it is our front view. So that means I'll be drawing the front view first. So 20 mm is 2 box. Put a point, that is A dash. Okay, so 20 mm it is done. Now you see that, so it is in first quadrant, we know its shortest distance from the XY line is 40. That means shortest distance from the XY line is 40 means we have to consider here, so X1 Y1 line. Okay, means from that intersection of that X1 Y1 profile line we have to draw an arc here. Okay, so for that we have to consider a scale here, and we have to consider 40 mm. So compass and measure 40 mm means 4 centimeter. So from this point to here take exactly 40 mm. Okay, so from this intersection point of this, okay, from this intersection point of this you draw an arc. Okay, after drawing the arc you mention the radius, okay, R40. So mention it R40. So after this what we do after drawing an arc, so from this front view we will be drawing a straight horizontal line, okay, as it is intersecting this point arc. So this point is nothing but our side view, that is A double dash. Okay, now we have to draw an top view. So for that what we do, so here in this case we will be drawing an 45-degree angle line. Okay, all the three views you have to draw, right? So for that we'll be drawing 45-degree angle line, 40, 45. So we can mark a point here. Okay, so this is our 45-degree angle line. Okay, now we can draw from this side view a vertical line until it touches the 45-degree angle line, and then draw, and from this point you draw an straight horizontal line. Okay, you know that the front view and top view are there in a straight collinear line. So we'll be drawing a straight vertical line here. Okay, so where these two lines are intersecting, this point is our top view. Now we can measure the dimension because it is mentioned in the question. You can see that draw the projection, determine its distance from VP. So we need to measure. So it is around 39 mm. Okay, so it is around 39 mm. So you can mention 39 mm. So this is what our shortest distance problem. So today we are going to learn on a single point how two or more views exist in a points problem. So we are going to discuss. So you can see the question. A point 30 mm above XY line is the front view of 2 points. You can see in this question, a point 30 mm above XY line is the front view of 2 points A and B. Okay, for the 2 points A and B is mentioning the front view, that is A dash and B dash, it will be lying above the XY line but a distance of 30 mm. Okay, so that's what it is directly mentioning. So we will be proceeding with the question. Okay, how it's mentioning. So this is another type of problem. Okay, so in this problem he is mentioning 30 mm above XY line, as we will be proceeding with the question. So 30 mm above XY line, so we drawn 30 and we have put a point. So this point 30 mm above XY line, it is indicating front view of 2 points A dash and B dash. So we'll be showing the dimensions. Okay, so that is our front view. Okay, the single point which is indicating two views, and it is lying at a distance of 30 mm above XY line. We have done it. Now we have to see, this is what the front views. Now we have to see for the top view. The top view of A is 40 mm behind of VP. So you can see the top view of A, is 40 mm behind of VP. So behind of VP means, there are two chances. So this is behind of VP. So either the top view can lie in second quadrant or it is in third quadrant. Okay, so we see in the third quadrant, so HP VP, so the top view is lying above the XY line, and third quadrant also HP it is lying above the XY line. You can see in this the point A is 40 mm behind of VP. Behind of VP means two chances, either it in second quadrant or third quadrant. In second quadrant also HP will be lying above the XY line, and in third quadrant also HP will be lying above the XY line. We know that the top view will be drawn in the HP planes. So that is when collinearly we have to draw the top view. Okay, already we have drawn 30. So we will be extending by 10 mm. Okay. So put a point, that is our top view. So 40. Okay. Now similarly, the top view of B is 45 mm in front of VP. So the top view of B is 45 mm in front of VP. So in front of VP means we know that there are two chances, either in first quadrant or in fourth quadrant. Okay, so in first quadrant, so where the top view is, so in fourth quadrant, so we know that HP VP lying below. So you can see this in the first and fourth quadrant, in both the cases the top view is lying below the XY line. So that means we will be drawing below the XY line 45 means 4.5 marks. 1 2 3 4 4.5 marks. Here you have to draw till here. So put a point, and this is your top view. Mention with the dimension line. Okay, so this is what the problem of on a single point two or more views. Okay, today we are going to start the first problem in points. Okay, so I'll take the first problem. Draw the projections of the following points on the same XY line, keeping convenient distance between each projectors. Good. Name the quadrants in which they lie. So first one, point A 30 mm above HP and 35 mm in front of VP. Point B 35 mm above HP and 40 mm behind VP. Point C 40 mm above HP and on VP. Next point D 35 mm below HP and 30 mm in front of VP. Okay, so this is the problem. Say the basic problem which you have solved, it is only the one point on the XY line. But you see in this problem, draw the projections of the following points on the same xy line. That is, on the same xy line, we need to project all these 4 points A, B, C, D on the same xy line. Okay, by keeping convenient distance between each projectors, and after that we have to name the quadrants in which they are lying. Okay, we need to mention either A is lying first quadrant, B is lying in which quadrant, and C is lying which quadrant, and D is lying which quadrant. So that thing we have to do it. So first we are going to draw an xy line. Okay, first we are going to draw an xy line. Okay, herein you should not write VPHP. Okay, should not write, because there are 4 points are lying on the same xy line. Okay, so now we'll take one by one. First we will take point A. Okay, you can see the question. A point A is lying 30 mm above HP and 35 mm in front of VP. So above HP and in front of VP means it is an first quadrant. Okay, it is in first quadrant, right? So in first quadrant we know that. Okay, for your reference purpose I will be writing. So for first quadrant, VP will be above X line and HP will be below the X. After drawing the projections, we will erase this. Okay, so 30 mm above HP and 35 in front of VP, it is in first quadrant. So we know that 30 mm above HP, above HP means it is front view. So front view will be lying in the vertical plane. So we draw 30 mm means 3 boxes, and you put a point. So this is A dash. Similarly, so 35 mm in front of VP. 35 in front of VP means it is top view. So 35 means 3.5 box. Okay, 35 means 3.5. 1, 2, 3, 3.5. Okay, 3.5 box you have to mark. Okay, and you put a point here. That is your top view. Now you draw an dimension line for showing the dimensions. Okay, so this is 30 and this is 35. So now we have done with the point A. Similarly, we look for the point B. So 35 mm above HP and 40 mm behind of VP. So above HP and behind of VP means it is an second quadrant. So point B is lying in the second quadrant. So after finishing this, you just have to rub it. Okay, remove this VP and HP. For reference, for your understanding purpose, you can write initially, then you can rub it. So 35 mm above HP and 40 mm behind of VP means it is second quadrant. We know that in second quadrant both vertical plane and horizontal plane are above the XY line. So 35 mm above HP means it is front view. So first we draw for 35, that is 3.5 box. Okay, and you put a point. Above HP means it is front view, B dash. Next 40 mm behind of VP, so it is in top view. Already we have drawn 35, so I will be extending by 5 mm, and you put a point. Okay, now we can write the dimension line. So this is 35, and here can show it for the 40. So it is 40. Okay. Okay, now we have done with the 2 points. Now point C. So 40 mm above HP. Okay, 40 mm above HP and on VP. So as we have discussed in the previous concept, so and on VP means it is our top view. Okay, it is our top view. So above HP means, so here above HP, so we know this concept. So HP VP. So above HP means the point may be lying in first and second quadrant. Okay, first and second quadrant. So the point may be lying in first and second quadrant. You can see that already we have completed the top view. Now above HP means it is front view. So now we have to look in for the front view. So front view in first and second quadrant. See, in all these cases you just see in the first quadrant, so where the front view is lying. Okay, VP HP. So front view lying in the vertical plane, it is above HP. Similarly in second quadrant also you have to see for the front view. So front view here also it is lying above the X view. So in both these cases front view is lying above XY. Okay, so front view is lying above XY. So first we draw a front view. So front view of, that is 40 mm above HP, it is in front view. So front view, it is lying in first and second quadrant. In both the cases first and second quadrant, the front view, it is lying in the vertical plane. So vertical plane, it is lying above the XY line, and similarly in the case of second quadrant also, vertical plane is lying above the XY line. In both the cases the front view will be projected on the vertical plane. That front view will be drawn above the XY line. Okay, so that's why you'll be drawing 40 mm line, 40 mm line, that is 4 boxes, and put a point. So that is front view. Okay, front view okay, 40 mm. Now, so we have this point on VP. So on VP means we know that it is in top view. So on VP means we need to project this point, that is top view, on the XY line. Please remember it. On VP means it is top view. This top view has to be drawn on the XY line. So okay, so here the point will be the point C. Okay, now similarly we will look it for the point D. So point D is lying 35 mm below HP and 30 mm in front of VP. So it is in fourth quadrant, correct? It is in fourth quadrant. So below HP, 35 mm below HP and 30 mm in front of VP, fourth quadrant. So we know that in fourth quadrant both vertical plane and horizontal plane are lying below the XY line. Now we see, so below HP, which it is in front view. So first we will draw in for front view. So that is 35, and you put a point, that is D dash. Okay, now similarly we have in front of VP. In front of VP means it is a top view. So here in both the cases it is projected below the XY line. I will put a point here, 30 mm. So it is top view D. Okay, now we are going to project it, draw with the projection line. Okay, so this is what, after drawing this, we'll erase these things. Okay, we'll erase these things. So this is we have written for our convenience. Okay, Okay, now we have to write down. You can see in this question we have to name the quadrants. Okay, we have to name the quadrants in which they are lying. Now we have to write for the first one, point A. So point A you can write here. A is lying. A is lying. We know that it is lying in first quadrant. Okay, A is lying in first quadrant. Similarly for the B we will write B is lying in second quadrant. Okay, B is lying in second quadrant. Similarly C is lying, you can see that C is lying in first and second quadrant. Both the things you have to write. Okay, because front view it is lying in first and second quadrant, so we will consider front view as a reference for writing it. So here in the point C it is lying in first and second quadrant, lying in first and second quadrant. Similarly for the point D we will write, so point D is lying, so point D is lying, we know that it is lying in the fourth quadrant. Okay, it is lying in the fourth quadrant.